Our next presentation is 1 AFRL, 2 Services DAF Deputy Technology Executive Officer for Space Science Technology.
Well, good morning, everyone. My name is Dr. Kelly Hammett. My day job is to be the director for AFRL's Directed Energy Directorate out at Kirtland Air Force Base, New Mexico. My night job is to be the Deputy TEO for Space S&T for the Air Force. So I've been appointed by General Pringle, the AFRL commander, to stand up this position. I'm in an interim role. And I am a champion and a change agent for how AFRL will support the Space Force moving forward. So I was asked to come here this morning and present just a few charts to you all on what's going on how the environment is changing, on how the names and faces and places are changing a bit with the stand up of the Space Force, and then to talk about how AFRL is aligning to those changes, and then of course maybe some opportunities for how you can engage with us to better support Space Force needs for science, technology, research, development, engineering, and technology transition. So if I can get the next chart, Justin. The title there says, 1 AFRL, 2 Services. As the Space Force was being stood up last December, that's when it was signed into law. Very quickly thereafter, many discussions at senior levels. Do we stand up a separate laboratory for the Space Force? And we went through several discussions of options, and the decision was made, no, let's keep 1 AFRL. We have many technology agnostic activities that could be harvested for space. If we carve out one separate space lab, then we may be creating some seams that prevent some useful technology development and transition. So that's why the title, 1 AFRL, 2 Services. On chart 2, this is what I was alluding to, in that there is so much changing very rapidly in the space landscape. We have the boom of commercial activities and development in space, primarily in LEO, proliferated low Earth orbit with SpaceX, Amazon, Virgin Galactic, a number of players you see over there on the left-hand set of charts. Of course, this is an updated chart. If I would have been briefing this 2 years ago, the words would have said space is a congested and contested environment, multiple ASAT tests going back years from China, India in the last couple of years testing ASAT weapons, Russia performing some malign activities in space. But what this chart is conveying is the realm, even though we were very worried from low Earth orbit up to geocentric orbit, we now have activities going on in what we call the cislunar realm, way out beyond the moon. There's probes and activities with many countries trying to get satellites out to the moon, out beyond the moon, capitalize on some of the what's called the Lagrange points, where you can have stable locations in between the Earth and the moon. A lot of this is potentially commercially driven, some national security driven. And so the challenge for us as a Space Force will be to maintain situational or space domain awareness out to this greatly extended volume. And what's indicated there in the middle is what we call the cone of shame. And that's because the viewing conditions out looking from the Earth toward the moon, unless it is completely in solar eclipse, is very, very bright. And so when we attempt to look with electro-optic sensors out into those realms to try to detect objects, to track objects, it's very, very difficult because of the brightness of those objects, because of the moon basically shadows them out. So the numbers in space increasing tremendously in terms of the number of countries getting involved. You can see that across the bottom, from going from the fewest world leaders in space to today, 50 nations and a vast commercial presence, all the way out to geo. And then where we see it going here in the next just few years is multiple more nations, potential non-state actors, certainly commercial ventures, and out to cislunar. And then the other key point that's mentioned there is for LEO and GEO objects, you're basically, from a physics perspective, within a two-body math problem when you talk about orbital dynamics, and that's pretty well understood. Keplerian physics or orbital dynamics apply. And so as long as you take periodic measurements and update a space catalog, you have a high degree of predictability of where objects will be unless they're maneuvering. Out in the cislunar realm, that's no longer true. The moon turns things into a three-body orbital dynamics problem, and the physics of the trajectories are quite unpredictable in many cases. And you basically can propel yourself out toward the moon, swing around the moon, and come back on a very rapid trajectory toward Earth, which has some significant national security implications. Let's go to the next chart, Justin. Okay, so this is, like I said, though, from a little bit older, that we have acknowledged, and at the highest levels of government here in the United States, from the White House on down, the verbiage has changed. We are acknowledging and saying that space is a contested domain, that there are threats proliferating in space, that we have to be ready to defend ourselves in space, that we have to preserve freedom of action in space. So just a few months ago, General Raymond signed out the document down on the lower right, which is the space capstone document. It's starting to formulate the doctrine for what the roles and responsibilities are for the Space Force. And you can see the second word there: enable joint lethality and effectiveness and provide independent options. So a fair amount of discussion over the last couple of years about will we rely on all the international treaties, and there's still a bunch of work on establishing expected norms and behaviors for space. What's considered a threat in space in terms of an object coming toward another object? How close do they get? How rapidly do they have to notify? All those types of things are still being worked. But from a Space Force perspective, we're working on the capabilities that let us have near in real time indications and warning of threats in space, and being able to react to those to defend our assets and make sure that we provide independent options for launch, resiliency, and continue to support the terrestrial and the air-based fight, which is the primary function that we use space for now from a military perspective. Let's go to the next chart. Okay, so historically, from the 60s on up, we have basically established functional areas in space that we needed to work on: communications, precision navigation, and timing. And we would basically stand up a system project office for that, a SPO, and dedicate a team and resources to go build off highly exquisite constellations of satellites that were intended to meet those specific mission areas. Not a lot of horizontal integration between those. Very expensive, very high mission assurance rates. That's why we've had GPS for the last 30 years, and it's worked extremely well, because we spent a bunch of time and money ensuring that the requirements were right, that the systems were developed. That takes a lot of time and a lot of money. And if you look back through the 90s and the 2000s, lots of cost overruns, lots of scale back of these constellations because of the way we do this. So we're currently in a pivot to what we're calling the hybrid architecture, where we don't spend all of our money on these multi-billion-dollar satellites in a tens of or 20s or 30s of billions of dollar constellations that are in fixed orbits, like I talked about earlier, with predictable behaviors and trajectories. But we're starting to mix up the orbitology, mix things up through LEO, MEO, GEO, and have the ability to move between those orbits, have small sats, have CubeSats, leverage the commercial activities that are booming across the world, and actually a lot of international collaboration as well. And then the bottom thing there is again multipath communication, not just always relying on the highly exquisite military owned and operated communication satellites, but purchasing commercial services for comm. That's also something that we're doing with imagery and internet, and so data links and those types of things. So that's where we're heading here in the next few years. And then, in the future, we want to have a highly complex web of satellites that are connected through what you might call the Internet of Space. This is happening terrestrially right now. You will see in the Air Force this thing called the Advanced Battle Management System and the 5G push. So in the air layer, we're trying to create this combat cloud of interlocked systems with multiple independent communications pathways. It's highly resilient and responsive. We're trying to have that happening the same way in space. And then probably the other thing that's not necessarily called out on this chart, but also the rapid ability to reconstitute or to add different layers into the architecture if we are attacked, if there are outages, if there are threats. So being able to also put up rapidly new capabilities is a major theme of the architecture moving forward. Next chart, please. Okay, so given that that's the landscape of where the global and international and cislunar architecture is moving, how are we pursuing space S&T in support of that architecture? This chart is an attempt to show that as well, that we will evolve and enhance our existing systems. So because we spent so much time on money on things like WGS and GPS and the other systems we have up there, we're not abandoning those. There will be incremental improvements, in particular with in terms of resilience, situational awareness on orbit, knowing that you're under attack and being able to do something about that, which those satellites, quite frankly, were not originally designed for. Then build out a resilient multi-layer architecture, as I said, spanning LEO to MEO to GEO to cislunar, and actually some interesting new work that we're pursuing on very low LEO orbits, mainly because of the unpredictability of the trajectories of systems in those orbits because of the effects of atmospheric drag. So a very resilient multi-layer architecture where functions are not allocated to a single constellation of birds, but those functions are distributed through the architecture, connect all those systems in the space layer, but also to the air layer and the ground layer. And then, there are some new things that we may go after from space. So one of the things that's been in the news has been some rocket-based cargo. SpaceX, in particular, working on launchable, reusable boosters. And given that you have that capability, you can launch things into space and return them to a terrestrial location across the globe much more quickly than you can with an airborne or a ship-based solution, which is how we move most of our military equipment these days, is by ship. And so there's a lot of exciting things going on as we look at the strategy for space S&T. One of the other things that's not in a bang box there, but it's down there, given that you have all these systems in a multi-layer resilient architecture, you really need to be able to command and control them in, as I said, near real time, not just every couple of days check in on things to see where they are or if they've moved. You've got to be able to do change of pattern of life, and realize when something has departed from where it was been historically and it's now headed toward a high value asset, or it's doing something that it wasn't doing before. We have to have that space domain awareness in near real time, and then we have to be able to command and control in near real time to respond to those types of situations. Next chart, please. So I talked about this a little bit earlier. One AFRL, two services is part of our response. And so within AFRL, we have for many years had a dedicated space vehicles directorate. Not as well known is that in my directorate, directed energy, about a third of my portfolio is dedicated to space domain awareness from the ground using primarily optical telescopes. And then out in the aerospace systems directorate in China Lake, sorry, not China Lake, Edwards Air Force Base. We have the Rocket Lab, which has been out there for a long, long time, pioneering propulsion and lift technologies to get us into space. So we have core competencies, we have dedicated assets, and then across the rest of the lab, there is, as I alluded to earlier, multi-domain technologies, materials, sensors, information systems that can be leveraged and dedicated to space. And so our goal is to be much more intentional in supporting those requirements and needs, and not break ourselves into different stovepipes, but be responsive as one AFRL to those needs. And so that's an evolving story. I can just tell you that last week we had a 2-day, all-day meeting with Space Force leadership on how to do this, the processes, the players, and how we're going to evolve things to be more agile, to be better focused, to leverage commercial, academic, and international activities. And so it's an exciting time, but a very dynamic and evolving time. Let's go to the next chart. Okay, so specifically, I'll just tell you, as the deputy CEO, I've been in this position for about 6 weeks now. And there is so much going on. It's very, very difficult to keep track of everything. But there are many upcoming business opportunities. I will just, for this audience, tell you guys to stay in contact with your local TD reps, to contact some of the appropriate organizations that I'll reference here in a moment. But in I think it was in October, SMC had an industry day. AFRL was part of that. You'll see more and more of a marriage of AFRL to include multiple directorates. AFWorks, if you're not tracking, AFWorks was recently reattached back to Air Force Research Laboratory. And so that helps us, again, with the one lab, two services model, to have all the pieces in an integrated way supporting Space Force needs. So from the AFWorks perspective, they organize a lot of what we call pitch days, which are meant to be very rapid opportunities to bring in both traditional and non-traditional space providers to bring R&D and S&T capabilities that we're looking for. There's an international space pitch day that I think was this week out of London. And so we also run those pitch days out of our accelerator locations. We have accelerator locations in Colorado Springs, Albuquerque. We're standing one up in Los Angeles. That will be a joint hub of AFWorks and SMC. And so you're just going to see a flurry of activity coming up here, including the SMC Space Pitch Day in 2021. AF Ventures is a shred out of the AFWorks portfolio. And we have Air Force Ventures, we have AFWorks Prime, and we have the SBIR Sitter portfolio. So the SBIR Sitter portfolio is being run out of AFWorks with input and support from the rest of the laboratory. For space, leadership has recently made a decision to stand up an AFWorks hub co-located with a Space and Missile Systems Center in LA with a Space Force deputy. And so you'll see a dedicated SBIR program for the tune of $20 million coming out of that. You'll hear announcements about the whole program. You'll see a dedicated Space Prime. And there's an Air Force, an AFWorks Accelerate event the second week of December, I believe it is, December 7th through 11th, to go into a lot more details about this. We're standing up a major OTA out here in Albuquerque. The Space Enterprise Consortium already exists. So that's another transactional agreement that's basically run out of the Prototyping and Innovation Directorate of SMC right now here in Albuquerque, but AFRL uses that agreement, and others can as well. You see there, as I said, rapid on-orbit reconstitution, servicing, programs in those areas, Agile Launch Initiative. There's just a lot coming up. So keep your eyes open for these solicitations. You can go to airforceresearchlab.com. Like I said, you can contact your traditional small business contacts if you're a small business, and get ready because there's a lot of opportunity coming. Next chart. Okay, so I went through that in about 20 minutes, so that there is time for questions and answers. Let me just, before I open the floor for that, say there is a new alphabet soup for the Space Force. Things are a bit confusing right now. The traditional organizations, I just referenced Space and Missile Systems Center, is going away. The old Air Force Space Command has already gone away. It was about 3 weeks ago. The new Field Command, known as Space Operations Command, was established, formally stood up. Lieutenant General Whiting took command of that. We are expecting to see Space and Missile Systems Center evolve into what's called Space Systems Command. That will happen sometime in calendar year 2021. AFRL will be attaching some of our dedicated assets, as I talked about earlier, space vehicles, Space Electro-Optics Division out of my directorate, and the rocket parts of the rocket laboratory out of Aerospace Systems Directorate to SSC, and reassigning them back. So again, a much more collaborative ecosystem. What that basically allows is Space Systems Command and the Space Force to own authority over their manpower and funding for those elements of space S&T. And then back in the core laboratory, in my role as the Deputy TEO for Space, we'll be evolving the policies and the processes to better leverage and align the rest of the portfolio to space needs, to identify opportunities and capitalize on those. Those include the basic research portfolio out of AFOSR, as well as all the other applied research at the 6.2 funding level that's going on across the lab. So I appreciate the opportunity to speak with you all today. It's a strange time doing all these events virtually, but we've adapted. I think they're working fairly well. I've been a part of a number of them. And with that, I'm happy to stop and take any questions you might have. So I'm not sure logistically if we're doing this through chat or people can ask questions online. Okay. For those doing basic research, I will say AFOSR has dedicated a certain level of funding for basic research that will be dedicated, and there will be annual portfolio reviews dedicated to space. We will have annual portfolio reviews across the rest of the portfolio as well, to make sure that we're committing enough resources and that we're meeting the priorities of Space Force. We've stood up some internal processes that are helping us manage resources. We're engaging with the Space Force on the programming and budgeting side of the house for space S&T. So again, an exciting time, lots of change coming, lots of opportunity, and I encourage you all to look for those opportunities and help us, because we won't succeed without our industry partners in this. As Dr. Roper is very fond of saying, the 80-20 rule for S&T has evolved to 80% of S&T funding is now coming from industry, 20% from the government. And so we're not gonna evolve rapidly into these dynamic changes, threats, and environment without really leveraging what our industry partners have to offer. So again, thanks for the opportunity. And we look forward to working with you all more moving forward.